Hello, ROS developers. This is Ricardo from The Construct, and I am here doing a re-recording of the ROS developers live class of today. That's live class number 58. I was trying to do the live class straight, recording it and delivering directly from the ICRA conference, the ICRA Robotics conference, but it has been a disaster with many cuts in the connection and many other problems. So, as I promised to all the attendants to the official live class number 58 at the proper time today, so I promised to do a re-recording with no noise, with no problems in the connection and everything, so you can follow and then go straight. So this is going to be just a recording of the whole process and going straight, no questions, because actually there is nobody here connected, so it is only myself and the ROS development studio. So let's go for that. One thing before starting, it's about the ROSjet link here. So you can still go to the previous live class chat and then you can get this ROSjet link here and then open the ROSjet in case that you're watching this video. So I'm not going to share the link here. So let's go. Let me open the ROSjet. That what is the live class of today is about picking an object from a table. And then on the previous live class, what we did is to configure our robot to be able to be moved by using the MoveIt package. We needed to configure that, so now in this second class we can use the MoveIt package for our robot and then to command that robot, command the arm of the robot to move to different positions, different locations, and in a very easy way. Okay, so on why we are showing this series of videos about moving an armed robot? Well, because our actual goal is to make a robot be able to grasp objects from surfaces, for example, from a table, from the ground, or from any other surface. And that's a very basic skill for a service robot that it is supposed to help us. So in order to follow this class, you should have a basic knowledge of ROS, what is a service, how to create a package, all this. If you don't know how, I'm here putting some courses that you can follow. Also, you have to understand TF. You have to understand how it works. And also you have to have a basic knowledge of MoveIt, that was what we saw on the previous live class. And then, yes, love for robotics. That's very important. Okay, so let's go on this class, and we are going to go straight to the simulation. So this is the simulation that we are going to launch and to use, and that's the robot that we want to use. So for that, let's go to simulations. The simulation is already provided inside this ROSjet that you are watching here that I have just opened. And in order to launch the simulation, we have to go to simulations and do from my workspace. So let's go here, simulation from my workspace. I click here, and then on the menu that appears here, I have to look for shadow gazebo / main launch. So let's look for the shadow gazebo here, main launch. So I select this one and then I launch it. So a new window is going to open here, and well, actually opened, and then let's wait until the simulation starts and we get something similar to what I can see here. And yes, that's a basic simulation to test our concepts. Then everything that we are showing here, you can apply to any other robot that has an arm, like for example the Fetch robot, the Tiago robot, or any arm robot that you are building, as far as you have the URDF properly configured, you know, the description of the robot. And here the simulation is starting and we are about to have it, because I see that the objects are getting loaded. So let me remove the simulation lock in the meantime that this is loading, and kind of got stuck here. It's loading the pieces. So yeah, maybe my connection is not very good neither here. This is at the hotel that I am recording the video, but yeah, but it's getting there. Okay, yes. So there it is. So we have the simulation. Then what we are going to do today is to learn how to send commands to this arm that now it has been configured with MoveIt in a very simple way by using a ROS program. And then we want the robot to grasp this ball over there. And for that, let's continue. We have the simulation running. And how does it work? Well, the MoveIt, what it provides, it's what is called the move group node. The move group node is a ROS program, yes, that is running there, and that is running based on the configuration that we created on the previous live class, number 57. In case that you didn't do the previous live class, I have put a link here at the beginning of everything. Here there is a link that you can visit and then go there. And then you will learn how to configure. So the move group is the node that allows us to send trajectories and positions to the joints of the robot by using very simple interfaces from our side. And for example, we can use a C++ interface for creating C++ based programs that send the commands to the move group that then afterwards they are going to be sent to the robot. Or we can use the MoveIt commander in Python. That's a class in Python that allows us to send very easily positions or goals to the arm. Or also we can use it our RBIS plugin that allow us to graphically indicate I want the robot put in this position. That's what we saw on the previous live class also. Okay, so now if we want to command our robot that is here, the simulation or the real one that was configured already for MoveIt, then we need to launch this move group for the robot using that configuration that we have created. So let's do it. How do we do? Well, if you follow the previous live class, you will know that we created this my robot MoveIt config package containing the proper configuration, and what we are going to do is to launch that configuration. Launching this configuration will create the move group node for our robot. Okay, so let's do it. How do we do? Go to Tools, Shell. Now we have a new shell here, and we are going to launch that command. So let me copy because it's easier and faster. You can type it and do tap to autocomplete, etc. So when this node group is going to launch, and then at some point in time we get this message, you can start planning now. When you see that, then it means that everything went okay and that we can start moving the robot. And we have the move group running. Then if we have the move group running, it means that we can create an instance of the MoveIt commander inside our Python program and start sending commands to the move group that is running here. And that's it. So what can we do, for example, with using the MoveIt commander in order to move the robot? We can do many things, but basically in order to send commands to the arm, we can send, for example, we can use the option of sending a complete pose that has been already predefined. So we can say to the robot, hey, please, robot, put in this position, let's say put in position A, and this position A was defined during the MoveIt configuration stage that we did last week on the last live class. So actually, if you remember on the previous live class, we created a start position. So we can say to the robot, hey, robot, go to the start position. So we just indicate a name, a label, and that's all. And then the robot will move up to this. That's very convenient. It's very easy. Another way to send commands through the move node using the MoveIt commander is to send a position for the end effector. Remember that the end effector is this point here, is this point here is where the actuator, the gripper, it's located, is the one that is going to perform the action. So we can use the move group to send a specific position only for that. And that's very convenient because by specifying only in which position we want to put the end effector, we don't care about which ones are the joint angles that they have to achieve in order to get this point at this location, for example, at the ball. So we don't care about how to do the kinematics for each one of the joints in order to achieve that position. That's very convenient. We are going to see in this live class how to do those two things. But we can also use the move group to send the goal position for each joint. So imagine that you have your own kinematic solver, and then you want to compute the goal locations, the joints for each one of the joints, and you can do that also. We are not going to see this one because it makes no sense here. And also you can even specify a trajectory to follow, not only the values of the joints, but also a specific trajectory of all the joints in the robot in a given amount of time. So I have included here a link to the official documentation where you can see how to do all the other two options that we are not going to see here today. Then what are we interested here is into perform a grasping. So pick an object from a table, that's called perform a grasping. And basically when doing a grasping sequence, we have 5 steps. This is for this case, but for any other case in a robot is usually, unless it's something special, but usually it must follow those 5 steps in the arm. So first you have to do is to bring the arm to a known position and open the gripper. So you are indicating that you are going to start planning from a position that you know that is safe for everything, for the arm and for start planning. And also you open your gripper and making it ready for grasping the object. Then once you have that, then you bring the arm to the location where the object is that you want to grasp, but you don't make it directly at the position where the object is, but instead you are putting close to this position, and so with a certain distance of security. Then finally, on the third step, you move the arm closer to the object until that object is between the fingers or the parts of the gripper. So now you have the object between the fingers, but you still have not grasped it. So that's the next step, that you close the fingers. So now you already have it. And the final step is to do an additional movement where you actually lifting the object from the surface where it is. That's when we consider that you have grasped the object. Okay, so we are going to implement all those steps in order to grasp the ball. Remember that here we are considering that we already know where the ball is. So it is supposed that some god came here and told us where is the ball. Okay, in the next live class, what we are going to see is how to figure out where is this ball by using perception. So here in this case we have this camera here that is going to provide us this scene, and then we'll see where the ball is. So we'll move the ball and then the robot will be able to go to the different locations. But for this class we are going to see only how to grasp the ball at this position that we know where it is. It's fixed. Let's go step by step, guys. We don't have to learn everything in one round. So let's go and let's create the grasping program that is going to grasp this ball. Then for that, I need to open another shell. Here, open the shell, and let's go to the CAD-King workspace. Remember that we have to go to CAD-King workspace source, And here is where we created our robot MoveIt config package. Now we are going to create another package that is going to be called catkin create package. It's going to be called my underscore grasping, and it depends on ROS Pi, because we are going to create a Python program with ROS. Then inside this this grasping, my grasping and source, I'm going to create here a file that is going to be called grasp underscore demo.py. And now that I am here, I'm going to change the permissions to executable. So I have this work already done. Okay, so now it should be shown in green. That means that I can execute this program. Now I'm going to create the content of this. For this, I'm going to use the IDE. So I go to Tools, and then I launch the IDE. It's easier for me and also for you to see the content of the code that I have created. So here inside the Catkin workspace source, then here I have my grasping, and inside source I have grasp demo. I'm going to open, and of course it's empty. Let me put it like this. Yeah. So now let's go and let's copy the first part of code that is included. So let me copy and then answer your questions. Explain the code, what it is. So after the import of the parts that we need to import, so of course the MoveIt commander, the ROS Pi, something in sys, and the geometry message that we are going to create later. And then what we do is first we initialize the MoveIt commander, and that's a way of doing it. So you have to learn this by rote memory. It's we are initializing the MoveIt commander. Remember, the MoveIt commander is the class that allows us to communicate with the move group, the one that we have launched here. And this one is the one that is going to communicate with the gazebo simulation here with the arm robot. Okay, so that's the whole process. Then we have the MoveIt commander, then we create the node, the ROS node here, and well, we get this robot here from the MoveIt commander, but actually we are not going to use it here today, but it's okay, so include it here. We are getting the robot that this MoveIt commander is going to command, and is going to command to receive commands. Yeah, so that's it, very simple. Then the first thing that we are going to do is the first step in the grasping sequence that I have explained here. First, send the arm to an initial known position. Then what we are going to do is to send the whole arm to the start position that we created during the MoveIt configuration last week. And this position is called a start. And what we do is first, we get the group of the robot, the group of joints that we call the arm. Remember that on the previous live class, we created two groups. We defined two groups during the MoveIt configuration. The first one is the arm. The group of the arm contains all the joints that actually compose the arm. So all those joints up to here. And then we created a second group that is the gripper that we have here. Okay, so we have two groups defined for this robot. And now what we are doing here is, okay, let's talk about the arm group. So we get here the arm group, and then we say, hey, for this arm group, please set the whole arm group into the target position that we define with the label start. Okay, so this is our target. We say, hey, arm group, I want you to reach that position, all the position defined as start. And then we call the planner and executor to actually execute this position in the robot. So that's what we do. First, we set on the arm group what is our goal, and then we say plan and execute on the robot. Plan and execute. It says this command go says both things. So MoveIt is going to try to find the plan from the current position of the robot to the final destination, that is the start position that we define. And then once it has found a plan about how to transition from this position to this start, then it's going to execute it. So let's copy this code and see how it works in the actual robot. So I'm going to add it here, and then I have to add a couple more of lines before finishing the program. This is just housekeeping of the program. Basically, it's closing the move group properly once the program has finished. And that's it. So by doing this, do you see how simple it is? We can move the robot, the whole arm, to a given position. Let's go. Let's try. Let's see how it works. So let me open here the terminal that I have opened before, and let me show you here the gazebo simulation so we can see the transition. So now let's ROS run my grasping, what was it called? My grasping, it's not also completing, my grasping, oh, grasp demo, yeah, okay, grasp demo.py. Okay, so I'm launching it. Then we should see moving this arm into the proper position that we have defined, and there it is. So, well, yes, I know it's very ugly position. Yeah, so I was playing around with the joints, and that's okay. So you see, okay, so we have learned how to send an arm robot to a specific position. Now let's do another thing more. It's about opening the hand. Remember that during this first step we have to do also this. So what do? We repeat the same process, but for a different group. Now we are going to get the hand group. The hand group, we call it gripper. Okay, so we have to add this hand group. Let me go to the code, and here beneath the first step, let me get the hand group. So I'm doing the same command here as I did for the arm. Now I'm doing the same for the gripper. Okay, so we have here the gripper, and then we apply the same procedure, but now for that second group, and we say, hey, open the gripper. And if you remember, for the gripper we define two positions, one open and another closed. We define this during the MoveIt configuration, so we can just send it, and then it's going to open and close the gripper. Now we are sending open. Okay, so let's try, let's see. So we have here the gripper. Now I'm going to run and execute again the program with this modification, and we should see the gripper opening. There it is. Great, we got it. Great, so we have the first step done. Then second step is to bring the arm close to the object, not on the object itself, so having the object between the fingers itself, but before that situation. And why do we do this step? Why don't we just send the arm here, just and put it at the proper location where it is closing the ball? Well, because the planners that we are using for moving the robot, they are not perfect, and then they have some trouble, and maybe it depends on where is the surface, where is at which height, at which location. Then the planner may try to reach that position by going from down or colliding against other things that are around. Then what we do is to plan the, it could also, the planner could also collide against the object that you try to grasp. So in order to prevent that, we say, oh, don't go to the location of the object itself, but a little bit higher in this case if you are doing a grasping from the top, or a little bit on the side if you are doing a grasping from the side to the object. In this case, we are going to do a grasping from the top. Okay, so that's the reason why we need to bring the arm close to the object but not at the object itself. And how do we do that? Well, I know at which position this object is because I have prepared this project, so that's why I know. And then what we are doing is creating a pose message containing the coordinates of the gripper, of the end effector that I want to achieve, okay, that is around here on the top, based on the wall frame, from the wall frame. Okay, so and that's what I'm coding inside the pose message. So what I do is to create a geometry pose message, and then I provide to that pose the orientation of the end effector and the position of the end effector in the wall frame. So instead of creating or indicating to the group that it has to move to a target position, to a target named position, what we are doing is to telling to the group to set to a pose target. You see here the call is different. Instead of set to name target, we are going to do to set pose target. And in the pose message, we encode which pose it is. And that's all. And then we call the planner again. Okay, that's simple. That's simple. Yeah, you can also, so let me copy this and add into the code. I'm going to put it then beneath the opening of the gripper. So we are, as you can see, we are putting one step of the sequence after another, and at the end we are going to have the full sequence in a single program. And that's it. So let's launch it. Let me show you the simulation so we can see what is happening and get a little bit further. Let's execute it then. Now what we should see is that the arm moves very close to the ball. Well, you can see this is one of the strange effects that could happen sometimes. This is what I mentioned about the planner, and when this happens, that's strange that it happened here in this today. That is why preventing this situation is, in order to prevent this, is why we set on this safe position here, but it didn't work now. So we have to repeat the process now. And actually, it's very likely that some of the physics of the system, of the simulation, they have crashed, and some of the controllers, they have crashed because of this collision between one object and another. So what we have to do now is to restart the simulation and restart everything. Yes, about this, about how to solve this problem if this happens in your robot. Well, that's why you should plan ahead and then plan before executing. So here we are doing the two things at the same time, but because I wanted to save time and simplify the system. But in another case, it's better if we if we have only the plan. Also, another thing that you have to do in order to prevent this is to include perception. So when you include perception into the MoveIt, then you are indicating where there are the obstacles. So the planner itself is not going to plan this kind of plan and not collide against the table or against this point here. So you can include all this information into the MoveIt planner. We are not doing this here. It was supposed to be a lot simpler, and then the planner has created a plan that is very stupid and colliding. So let's go and let's relaunch the simulation, because it's very likely that it's not going to work. So let me relaunch it, and also close this MoveIt config because it's not applying anymore to the simulation, the previous simulation. Then yeah, so that your next question could be why this plan has been generated and why it's not going to happen again here on the second try? Yeah, because those planners are kind of random. They have a random factor where they are searching for the solutions, and then that's why it's not going to happen again. Well, maybe it will happen, but I will be very surprised because I have tested this many times on the preparation and never happened this situation. So simulation has been launched. Now let's go again to launch the MoveIt config, and let's wait for the planning. Yeah, there it is. And now let's launch again our grasping sequence. So we should see the whole sequence of the 3 points: starting position, opening gripper, then moving close to the ball, and there it is. Okay, so you can see that we are close to the ball but still not ready to grasp it, to close the fingers. Okay, so now let's do a third step, that is to get the hand closer up to the position where the robot is going to close, is going to be able to close the finger. So let's come here, copy this sequence and go to the IDE that is around here. Yeah, and let me put it beneath this option. So what are we doing here? It's actually we are applying the same process as in the previous movement, but the only thing that I'm doing is changing the pose that I have created on this step, and the only thing that I'm changing is the Z. So the height, the height of the end effector. So I'm changing it a little bit, so then it is supposed that the gripper should go down just a little bit, but on the same coordinates with the same orientation. So that is why I'm only modifying this. And then I'm doing the same type of call, setting the pose target and then group go. Okay, so let's go and see that how it works. Let me launch it, and then we should see the whole sequence being performed again. So first go to the start position, then let's go open the gripper, go to close, and then closer. There it is. Okay, so there it is. Now you can see that the ball, the object, is between the fingers. Yes, and I think that even we should get it closer, because I don't know if we are going to be able to grasp it. Now, I think it's not too close. Well, we'll see in a minute. So we are ready to close the gripper. That's the fourth step. And how do we do this? Well, applying the same mechanism that we have done previously. So it is calling a target pose for the gripper group. And you remember that we called it with the open. Now we are going to call with the close. So that's it. Let's go and let's do it. Let me launch it and let's see the whole sequence. Again, going to start position, opening gripper, going close. No way, no. Oh, okay. Okay. Okay, so yes, very good. So this is very funny. Thank you very much. I have to launch it again, and here things are crashing, everything. So let's go again and do it again. Yes, let's start again the simulation, and let's start the MoveIt commander here. The MoveIt, sorry, the move group, I mean. And let me see. Okay, so that it has been started. Then I'm going to launch the move group and then launch the whole sequence of grasping. you know, the theory is always very good, but when you start working with the robots, even in simulation, you can see so many problemms do arise until you get, and it's going to do the same thing, the same stupid, well, not the same, but something quite stupid. Okay, so now we are getting, and then it has been closed. It's been closed. I think it has grasped properly. Yes, it's between the fingers. Now we are about to grasp it. Oh, okay. Yeah, there it is. Okay, great. We got it. Now what we are going to do is the final step, that is to lift the object. That's it here. So let's add this to the code, but I'm going to do some trick here because I don't want to lose the ball and then it's going to move from the current position. If I lose the ball that is there, if I open now, the ball is going to move, so I will not be able to do it. So let me just remove here everything. So when I execute this sequence, it's just removing for now, so it's only going to leave the arm. Okay, so it's not going to perform all the sequence of movements. Then let me launch it and we'll see how it moves up, and then afterwards I will restore the whole code. So we should see, oh sorry, there is a problem here. Post target is not defined. Let me see. Post target, yeah, okay, yes, that's right. So let me restore the whole program here, and then post target, yes, because I haven't created this. Okay, so it's a little bit tricky. Then I'm improvising here, so let me do this like this, and then let me do this like I have to do the gripper, so I need to have the arm group. Yes, so I need to remove all this part. Okay, this is just for this video. Okay, so in your case you should create everything, and so don't try this at home. Okay, so let's see. And there, oh, it slept into the between the fingers. It slept between the fingers. Okay, so then now let's restore everything. So we have let me see here, and close the fingers and put the arm. Yeah, so now we have the whole sequence here. Restore and saved. And now let's execute everything. Then if it has, I don't know if I have to stay at the same position, exact position, but we can launch it here now, and we can see the whole sequence. Okay, doing stupid things, crashing against the wall. Yeah, now going, yeah, so it has crashed, and because, yeah, so it didn't work. Yeah, let me see again, let me launch it again. Should go straight to the initial position. Open the gripper. Yes, now go to this location close to the ball, then get closer, close the fingers, grasp the object, and oops. Okay, so there is something wrong here in the strength of the joints, that it's kind of the physical contact of the ball is not allowing the robot to grasp it for some reason. So I don't know, but you get the idea. Okay, so you know how it works. So it has worked. The whole sequence would be that in this way, and then there is a problem in the strength of the joints of the gripper for keeping that grip, not opening when there is the contact with the ball. But basically that is the process. So there is nothing more to be shown on this. And then so in the next live class, we have finished here. On the next live class, we are going to add perception about how to create how to find the position of this ball, and yeah, so we'll be able to move the ball around and then see if the robot is able to find the proper locations. And I will look at that point for the gripper to create a stronger gripper, so we are not going to lose the ball. Okay, so that is going to be for the next live class. Remember, let me remind you about the ROS Developers Conference. That is a practical conference, ROS online, you don't have to travel, and where 8 speakers are going to explain you different lessons in the same way as you are having this lesson here. You can see more information here. And I have to run in a rush because my battery is about to die. And thank you very much, and see you next week. Bye bye, guys.